This is mathheals.com, where you can go to get more links to other math YouTube videos. Let's take a look at natural exponential functions. Now, let me refresh our memory on some properties. Now I'm going to put these specifically in terms of the natural exponential functions. Now when we're talking about a natural exponential function, we're going to have an e to a power. So if we have e to a power times e to a power, take my glasses off out there, we're going to add the exponents. So e to the m times e to the n is equal to e to the m plus n. Now if you have a e to a power raised to another power, you multiply the exponents. So that'd be m times n. If you have e to the 0, that's equal to 1. If you have e to a negative power, and I'll actually put a number here, like -2, you want to move it opposite of where it's at in a fraction. So we create a fraction, if there isn't one already there. So I'll put that over 1. And I'll take the e to the -2 down to the denominator, and it becomes e to the +2. So when you got a negative exponent, you just take it opposite of where it's at in a fraction. Now consider if I had e to a power down here. So we have -3. Again, you take it opposite of where it's at, so I take that up on top. And you always put a 1 as a placeholder in the other position. Sometimes it disappears, but now if you have a fraction, let me actually put like 1 over e. If you have a fraction to a negative power, like -2, what you do is you flip the fraction, and then the sign of the exponent becomes positive. Now, if you have parentheses to a power, and everything inside is either multiplication or division. So everything inside is either multiplication or division. Then what you do is you take everything to that power. Now if you have addition or subtraction in here, you can't do that. But if everything inside the parentheses is either multiplication or division, then you take everything to that power. Some books just list that as like 2 items, but it can be however many. It can be multiplication or division. Now if you have e to a power over e to a power, a lot of books list that as subtraction, but I like to think of it differently. What you do is you subtract the smaller power from the larger. So subtract the smaller power from the larger power, and you have e to that power where the larger exponent was. So subtract smaller power from larger power, and you have e to that power where the larger exponent was. Now there's some other properties, but these are some of our main ones we'll look at. Let's work on some problems. we have e to the fourth times e to the fifth. Well, if we have e to a power times e to a power, you're going to add the exponents. So we've got 4 plus 5, which gives us e to the ninth. Now, we don't take that any further. We can't really get an exact answer by taking it further. This is our exact answer, the only closest we can get. Now, e is 2.7 and a bunch of decimal places. And so when you take it to the 9, it's just a whole bunch of decimal places, and you'd have to approximate it. You have to round it. Which is okay sometimes. Well, here we have e times e to the negative 6. Well, remember, e is like e to the first. And if you have a negative exponent, you want to move it opposite of where it's at in a fraction. So I need to create a fraction. So I'll put all this over 1. Now we're going to take the part with the negative exponent opposite of where it's at in a fraction. So the e to the negative 6, I'm going to take down to the denominator. And we get e to the first over e to the positive 6. So when you move something opposite of where it's at in a fraction, the sign of the exponent changes. Now, if you have e to a power over e to a power, you subtract a smaller exponent from the larger one. So 6 minus 1 gives us 5. And we're going to have e to the fifth where our larger exponent was, which was on the bottom. And then we put a placeholder of 1 up on top. So our answer is 1 over e to the fifth. Here we have e to the seventh raised to the third power. Well, if you're raising one exponent to another exponent, you multiply the exponents together. So let's take 7 times 3, which gives us e to the 21st. In this one, we have e to the negative 2. Again, we don't want negative exponents. We move them opposite of where they're at in a fraction. So I need to put it in fraction form. So I'll put the e to the negative 2 over 1. And we're going to move the e to the negative 2 down to the denominator. And it becomes e to the positive 2. And we'll put a placeholder of 1 there. Again, when you move anything opposite of where it's at in a fraction, sign of the exponent changes. Let me say this is natural exponential functions. Page 01.pdf. And let's look at the next problem. So we got e to the third raised to the 4/3 power. Well, again, when you're raising one exponent to another exponent, you multiply the exponents together. So I'm going to take 3 times 4/3. Now when I do that, those 3's going to cancel. So we end up with e to the 4th. Now b, we have e to the 1/3 times e to the 4th. Again, you have e to a power times e to a power. You add the exponents. So we're going to have e to the 1/3 plus 4. Now this is a mixed number. So what I can do is I can take that 4, multiply it times the 3. 4 times 3 is 12. And we'll add 1, and that gives us 13. So we've got 13/3. And that's our answer. Let's see, this one we got e to the negative 4 raised to the negative 2 power. Now, typically, when I show these, I like to follow my order of operations. Please excuse my dear Aunt Sally. Do what's inside the parentheses and so forth. But this one, I can't help but go ahead and use this shortcut. If I go ahead and raise this to a power, I multiply the exponents together. Negative 4 times negative 2 gives us a positive 8. And that's our answer. We get e to the third over e to the negative 4. Again, we don't want any negative exponents. So I'm going to take whatever's a negative exponent opposite where it's at in a fraction. So I take the e to the negative 4 up on top. And so we get e to the third. Try that again. There we go. E to the third times e to the fourth. Again, when you move anything opposite where it's at in a fraction, the sign of the exponent changes. So it becomes e to the positive 4. So we got e to a power times e to a power. We're going to add the exponents. So 3 plus 4 gives us e to the 7th. And that's our answer. Next one wants us to sketch this. And let me just do one kind of using a t-chart, and then I'll use a calculator for the rest of them. Okay, so we have f of x is equal to e to the 3x. Well, I'll do negative 2, negative 1, 0, 1, and 2. So this would become e to the 3 times negative 2, which is e to the negative 6, which is 1 over e to the 6. Now I'm not going to actually do this completely by hand. E is, like I said, 2.7, bunch of decimal places. So I do 1 divided by, and how you get e on your calculator is you do second ln. That's the natural log. And then you put 6 in, and then press enter. 0.002. Pretty close to the x-axis. Negative 1. So I got 3 times negative 1. That gives us e to the negative 3 equals 1 over e to the positive 3. It's 1 divided by second ln, and then 3. And we get 0.05. Then this one would be e to the 3 times 0, which is e to the 0. And anything in the 0 power is 1. This one would be e to the 3 times 1, which is e to the third. So if I do second ln, put in 3, get 20. There's really not much need to do this other one, but let me go ahead and, since I put it in my t-chart, put the 2 in for the x, and we got 3 times 2, so e to the 6. It's going to be so huge we're not going to be able to find it. So second ln and 6. 403. So 0, 1. Negative 1, 0.05. So that's like almost right on the x-axis right now. And 0.02 is right there. 120. Now, I'm not going to even be able to put that on here, but that's like way up there. So when I graph this, it'll come down and go like that. Now to do this on your calculator, there's a calculator. I'm going to press my y equals. I'll press clear. To get to e, again, we do second ln, and then I'll put in 3x. You don't have to put closing parentheses unless you want to. Then I'll press graph. And we get a little bit better picture. The key thing to remember is these never just stop. This keeps going forever. Just got so close to the x-axis that it's skimming it, and it looks like it's 1 with it. This is actually a horizontal asymptote, because this can never equal to 0. Let's take a look at some more on the calculator. Got f of x is equal to e to the negative x minus 3. Sketch it. So come over here, press y equals, press clear, do second ln, and then we got negative x minus 3, so negative x minus 3. You can put a closing parenthesis if you want, but I'm just going to press graph. And that would be our answer there. So it looks like, I didn't draw it real well, but you get the idea. Looks something like that. Here we got f of x is equal to e to the x plus 2. So I'll come here, I'll press y equals, press clear. I'll do the e, so I do second ln, natural log. And it puts a caret and puts a beginning parentheses. We want to put the x in here. Now here you have to close the parentheses because the x is the only thing that should be up in the exponent. If you got one of the near TID4s, you have to press your right arrow key to get out of exponent mode. And then do a plus 2, and then graph. And let me kind of sketch it here. And that'll be our graph. Let me save this. And let's look at our next problem. Got f of x is equal to 3 over 1 plus e to the negative 2x. Now the instruction is a little bit different here. It says sketch the function. So we're going to go ahead and plug this in our calculator. And then it says determine whether the function has a horizontal asymptotes and discuss the continuity of the function. Well, it's hard to discuss the continuity of it, but let's go ahead and graph it first. The key part on graphing this is if you have a fraction, if you have more than a single number or a single variable in top or bottom, then you want to put parentheses around top and or bottom. Well, the top is okay, but the bottom, we have to put parentheses around it when we plug it in our calculator. So I'm going to come here, I'm going to press y equals, press clear, 3 divided by, and I'll put beginning parentheses around the bottom part, then 1 plus second ln for the e. Now it puts the caret and puts the beginning parentheses. We're going to now put negative 2x. Now I'm going to put a closing parentheses on the power and closing parentheses on the denominator, although TI3, TI4 does not require any closing parentheses at the very end. And then we'll press graph. Okay, so looks something like that. They never just stop. This keeps going forever. Now, if we were to, you can kind of look at it and see, but if I were to find the limit as x goes to positive infinity of this, well, this is the same as the limit as x goes to positive infinity of 3 over 1 plus 1 over e to the 2x. And if I were to put the infinity in there, we'd have 3 over 1 plus 1 over e to the 2 times infinity, which 2 times infinity is infinity, 2 to infinity is infinity, so we got 1 over infinity, which is 0. So this would give us 3 over 1 plus 0, which would give us 3. which kind of makes sense. For horizontal asymptote, it looks like it's skimming 3. Now the other side is not so easy to see, but the fact that it's an exponential function, e to a power, we know this can never equal to 0. Well, we haven't, in this particular book, haven't covered how do we solve that, and that's why it's a little bit challenging. If I looked at just the e to the negative 2x, and we set it equal to 0, saying that it's actually going to touch the x-axis. Well, to solve for this, and again, we haven't covered this in the book yet, but if you take natural log of both sides, natural log and e cancel each other out, and you just be left with negative 2x. So that's how you get the variable out of the exponent. But natural log of 0 we can't have. So it can never equal to 0, which means that's an asymptote there. So it's skimming that right there. Now continuity. Again, we can't really discuss the continuity because whenever we have a fraction, remember we set the denominator equal to 0 and solve it? Well, this is where it's discontinuous, whereas where the denominator is equal to 0. This is the continuity. But again, we're talking about something we haven't really covered yet. If I bring the 1 over negative 1, if I take natural log of both sides, that's how you solve an exponential equation. We get log of a negative number, which we can't have, which means it's continuous everywhere. So our continuity is it's continuous everywhere. We can put any value in for x. Now these next problems deal with the interest formula. Now let me read the problems just so we see just generally how they read. Complete the table to determine the balance A for P dollars invested at a rate R for T years compounded N times per year. And P is 2,000, R is 3.2%, T is equal to 15 years. And we got N is equal to 1, 2, 3, 4, 12, 365, and then continuous compounding. Well, we got two formulas we're going to be working with here. These are our interest formulas. And one of them, it doesn't say continuous. Let's try it again. I'll learn to write someday. So it doesn't say continuous. That's this formula. A is equal to P times 1 plus R over N to the NT power. And the other one, it actually says continuous. Specifically, it'll say compounded continuously. And this will say compounded quarterly, compounded monthly, compounded, whatever. This is the PERT formula here. Well, A is our ending amount. P is our beginning amount or principal. R is our rate, and it's in decimal. And T is our time, and it's in years. N is the number of times compounded per year. So the number of times compounded per year. Now, compounded is a fancy word to say calculated. So they calculate the interest, and then they take that interest and they put it back into the account. So it keeps accumulating, keeps compounding. Now, if it says annual, it's compounded annually. N is 1. If it says semi-annual, N is 2. If it says quarterly, n is 4. And let me scoot down a little bit. There we go. If it says monthly, n is 12. If it says weekly, n is equal to 52. If it says daily, n is equal to 365. And if it says hourly, n is equal to 365 times 24. So 365 days, 24 hours in a day. So those are our values for our n. Now this formula goes ahead and just puts the n in the table here. So doesn't use the words. Let me save this, and then we'll start doing this on the next page. Okay. So for number 8, they tell us P is 2,000. R is 3.2%, and T is 15. And we're wanting to find A. It says complete table to determine the balance A for P dollars. So we're wanting to find A. Now here, these first ones are the first formula, because they didn't say continuous. So let me do n is equal to 1 first. So we're going to have A is equal to P times 1 plus R over N to the NT. P is 2,000. 1 plus R, which is 0.032, over N, which was 1, raised to the NT power. So it'll be 1 times 15. And that's just 0.032. It's better to do a little bit of this in your head by hand before you plug in your calculator. Now the part I'm specifically talking about is the n times t power. So 1 times 15 is 15. Now let's go plug it in. So I want to exit out of graph mode here. Put in 2,000, beginning parentheses, 1 plus 0.032. And actually that was divided by 1, wasn't it? Yeah, let me go ahead and divide by 1. Close parentheses, caret, and then 15. Enter. And that gives us our answer. 3207.93. Let's do our next one. N is equal to 2. Again, it's the same formula. So we got A is equal to P times 1 plus R over N to the NT power. So we got 2,000 for P, 1 plus R, which is 0.032, divided by N, which is 2, raised to the NT power. So we got 2 times 15. Again, it's good to do a little bit of this in your head. 2 times 15 gives us 30. Why did I put a 1 in that first one I plugged in the calculator? You probably were looking at it as like, well, that doesn't make any sense. Well, if I do a second enter, it brings up the previous entry. And if I have the 1 there, all I have to do is go and change that and put a 2 there. So it's nice to have the value there. And then this is 30. So I'm going to right arrow over, and I'll put in 30. So again, second enter brings up your previous entry. And then that gives us that value. The next one is n is equal to 4. So again, using the same formula. So we got 2,000 for P, 1 plus 0.032 divided by 4, raised to the 4 times 15 power, the NT. So we've got 2,000, 1 plus 0.032 divided by 4, and then 4 times 15 is, what is that, 60? So again, I'll bring up previous entry. I'll do second enter. And go over to the 2 and put a 4 in. And then go over to my power. Instead of 30, I'll put in 60. And that gives us that value. Okay, so let's continue. N is equal to 12. So I got A is equal to P times 1 plus R over N to the NT power. So we got 2,000. 1 plus R, which is 0.032, divided by N, which is 12 now. Raise the NT power. So we got 12 times something. What was T? T is 15. I really don't know what that is, 12 times 15, so I guess I can't do that in my head. And I have no clue what it is I just wrote down there. Let's try it again. Okay. Divide by N, which was 12. There we go. Now when I plug this in, if I don't do this separately, what I have to do is I have to put parentheses around it when I plug in my calculator. Whenever you have more than a single number or a single variable in your exponent, you have to put parentheses around it. So let me type this in. 2,000 beginning parentheses 1 plus 0.032 divided by 12 closing parentheses divided by beginning divided by, let's try that again. That should be a caret. We're raising to the power. And then beginning parentheses and 12 times 15. And then you can put a closing parenthesis if you want on that. And then enter. And we got 3230.08. Okay, next one I think is 365. Again, it doesn't say continuous. We're going to use the same formula. So we got 2,000, 1 plus 0.032 divided by 365, raised to the NT power, so 365 times 15. Again, when I plug this in, I want to put parentheses around that. Now there is a way to insert by doing a second enter, bring up the previous entry on your calculator. It's probably just as easy just to type it in brand new though. So if it has more digits, like this has 3 digits instead of 1 digit or 2, then just type it in again. 1 plus 0.032 divided by 365, closing parentheses, caret, beginning parentheses, 365 times 15. Closing parentheses, enter. 3232.08. And then our last one, continuous. So it's compounded continuously. Well, that means we use our PERT formula. So we switch over. Now P is 2,000, E to the R, which is 0.032, times T, which is 15. I'm going to put a little times here, and then 15. You have to be careful when you plug this one in your calculator. Okay, so I'll put in 2,000. Now to get to E, do second ln, second natural log. And then we got 0.032 times 15. And then enter. You're best not to put any extra parentheses on that when you're doing it. So 3232.15 would be your answer. What people will try to do in this problem is they'll put 2000, they'll do second ln, 0.032, closing parentheses, beginning parentheses, 15, closing parentheses. And that seems logical, because parentheses next to each other indicate multiplication. But when you press enter on that, you come up with some huge number. Again, when you're plugging these in, do not put any extra parentheses on them. Okay, now let me do this problem again, and I'm going to do it in Excel. Of course, you can't have Excel on a test, or not all the time, so that's why I want to show it on the calculator. Though there is even a shorter way to do it on the calculator, but I just wanted to show the very basics, so if you didn't have a TA3, TA4, you could still do it. Well, we got three items: principal, rate, and time. So we're going to have principal, rate, and time. And we'll put them in these boxes here. So we got 2000, 3.2, and 15. And then table here, we got in, so 1, 2, 4, 12, 365, and continuous. And then this will be A here. Now, okay. Let's look at our formula. We got A is equal to P. So here I'm going to do an equals. And I wanted to point to the P. So I'm going to do a $B, $1. That's absolute referencing, so it'll always point to B1. And then times, and if you're wondering what in the world I'm looking at here, I'm looking at this formula right here. That's one we're plugging in. And then times, so I do an asterisk. And then beginning parentheses, 1 plus R. So I'm going to do, and I'll put this in the beginning parentheses also. And R is $B, $2. That's absolute referencing. And then I'll do that, I'll take that and I'll divide it by 100. Because we want to put it in decimal form. Then close parentheses. And then we'd have divide by n. Now n is in B5. So I just type B5. Now notice I don't put the dollar signs on that. That's not absolute referencing there. And then after the n we'll have a closing parentheses. And then we'll do a caret for our power. And then we'll put a beginning parentheses, and we want n, which is B5. Again, I don't put absolute referencing there. Times t, so to the nt power. So times, and t is B3. So I do $B, $3. Close parentheses, and enter. And that gives us our same value there. Now if I click this cell and I put my mouse down in the lower right hand corner, it becomes a plus. If I click with my left mouse button and hold down and drag it over here, there, I see I got 3219, 3225, 3230. It gives me all my different values. Okay, what does the dollar signs do? Okay, so I put dollar signs around those, but I didn't put them around these B5s. If I come over here and look at my formula, you see how this still points to B2 and so forth? But this now switches to C5, so it points to the N right above it. This one right here, if I look at that formula, see how it points to D5? If I put an absolute referencing on these other ones with the dollar signs, it'll always point to those, no matter how much I fill over. But these other ones be relative to what column it's in, and see it changes it appropriately. Now our continuous, that's the PERT formula. So equals our principal, which is B1, and I'll do absolute referencing, times E, which is EXP, raised, and you don't have to do a caret or anything. You just do exp beginning parentheses our rate, which is $B $2 times time. So times, and then $B $3 closing parentheses. So A is equal to P e to the RT power. If I press enter, did I put that in right? B1 principal times exp to the B2 times, oh, I didn't do divide by 100. Sorry. There we go. Remember, you got to switch your rate to decimal form. So you have to do divide by 100. And if I check that, then it gives me that. What's nice about this is you're not working in a business where you're having to calculate interest or whatever formula you're working with. Well, now if I come up here and somebody comes in and says, okay, well, my principal's now 5,000. I can come up here and change that to 5,000, and it automatically gives me all my updated values. Versus me having to redo these formulas 6 times. This is very inefficient here. Excel is the best way to do something like this. And now I can save this spreadsheet and use it for the next 20 years and be fine. So very nice to do some of this stuff in Excel. Now I'm not going to be real tedious with this and do all of them by hand anymore. I'll do one of them by hand, then I'm going to go and do it in Excel. So for this next problem, number 9. It says, complete the table to determine the amount of money P that should be invested at rate R to produce a final balance of $200,000 in 2 years. It says right here, compounded continuously. So that's our PERT formula. Now we're trying to find out what P is. So to get P by itself here, I'm going to divide both sides by e to the RT power. So if I divide both sides by e to the RT power, those are going to cancel. And we got P is equal to A divided by e to the RT. So that's our formula we're going to be working with. Now they say we want a final balance of 200,000, so they're telling us A is 200,000. R is 4.1%, which we know we're going to want decimal, so that'll be 0.041. And then it says what is P when like T is equal to 1. So we'll just do T is equal to 1. So we got P is equal to A over e to the RT power. A is 200,000 divided by e to the R, which was 0.041, times 1. Now you have to be careful when you plug these in your calculator. Let me come over and show it. Put 200,000 in. Is that 200,000? No, that's 20,000. 200,000. Then divided by E you do by second ln 0.041 times 1. And then enter. And that gives us 191,965.83. That's how much our principal would have to be in order to end up with 200,000 after 1 year at this rate. Now, actually, let me do one more. I lied to you. T is equal to 10. So I want to demonstrate this. Of course, it's the same formula. E to the RT. So we're going to have 200,000 divided by e to the 0.041 times t, which is now 10. Why did I show this one? Well, because if I come to my calculator, if I do second enter, it's exactly the same formula, except for instead of 1 at the end, we'll have 10. So if I do my left arrow key, here's a 1, I'll just put in 10 and push enter. And that gives us 132,730.05. Okay, since this is so easy, let me just go ahead and finish this. So we got t is equal to 20, t is equal to 30, t is equal to 40, and t is equal to 50. Okay, so I'll come over here, I'll do second enter, bring up the previous entry, and I'll do my left arrow to go back and change that to 20. Enter. And then our P would equal to 88,086.33. Now for T is equal to 30. Again, I'm going to come over here, do second enter, use my left arrow key to go over and change that to 30, and press enter. And we got P is equal to 58,458.52. For T is equal to 40, I do second enter. That is such a nice feature on the calculator. Bring up that previous entry. And after I put 40 in, press enter. And P would have to be 38,796.01. I don't got my glasses on, so hopefully I'm writing these down correctly. And then I'll do a second enter, and I'll put 50 in. And we got P is equal to 25,746.98. Okay. Let's see how to do it in Excel. Of course, this is our main formula we're working with right here. So I'll come over here to Excel. And A is my ending amount. And I also need R, our rate. We said our ending amount was going to be 200,000, and our rate was going to be 4.1%. And then, what are we wanting? If I can find it here, T. 1, 10, 20, 30, 40, 50. And this will be our principal. So I'll come down here and I'll do an equals. That's how you do a formula, is with an equals. And where's our formula? I'll eventually find it. Here we are. A divided by, so let's start there. A is in B9. And I'm going to do a dollar sign B, dollar sign 9. That's absolute referencing. Divided by. And then we have e to a power. So I'll type exp for the e to a power. Beginning parentheses. Our rate, which is in dollar sign B, dollar sign 10. Now I have to change that to the decimal, so I do divide by 100. And then times T, which is in B12. Now notice I use relative referencing there. I don't put the absolute value bar or dollar signs before it. And then I press enter. And now, since I've done the absolute and relative referencing, I can fill that over. And you see I get the same values. Excel is so nice for this stuff. Getting used to these formulas will prepare you for working in the workforce. If you're an accountant, if you're a manager, and you have to do any kind of calculation at all, use formulas, you should be using Excel. It saves so much time. Now if somebody comes in and they want to know, okay, I want my ending amount to be 500,000. You change that to 500,000, you automatically got your new numbers. your rate changes on your account. It's now 3.12%. Come here, put in 3.12. Now it changes it automatically. It is so nice. Okay, enough of that problem. Let's go to our next one. This says complete the table, determine the amount of money P that should be invested at the rate R to produce a final balance of 200,000 in T years. It's compounded weekly. So this is the other formula. Let me save this. There we go. And 10. Complete table determine that should be invested to produce a final balance of 200,000. So A is 200,000. R is 2%, or 0.02. Compounded weekly. That means N is equal to 52. And then they want to know for time T equals 1. Okay. Well, the formula we're going to be working with is A is equal to P times 1 plus R over N to the NT power. Now what they're wanting to solve for is they want to solve for P. Well, I can divide both sides by what's behind my P here. So A divided by 1 plus R over N to the NT power. These are, a lot of times they go ahead and give you these formulas for finding present value. We're actually showing the calculation for it, but those cancel. And we've got P is equal to A over 1 plus R over N and to the NT power. Now when you plug this in, whether it's on your calculator or in Excel, anytime you have more than a single number, single variable in your exponent, you have to put parentheses around that. So when I plug this in, I want parentheses around the NT power, like that. Okay, so for our first one here, A was 200,000 divided by 1 plus R, which is 0.02, divided by N, which is 52, raised to the, and I'll put parentheses around the exponent here, NT, so 52 times 1. And let's see what this gives us. So we got 200,000. There we go. Beginning parentheses. Line dia. 200,000 divided by, and then beginning parentheses. 1 plus 0.02 divided by 52, closing parentheses, caret, beginning parentheses, 52 times 1. I'll leave the closing parentheses off the end of that because you actually don't need it at the very end on a TA3, TA4. Plus 0.02, let me double check everything. Yeah, it looks good. Press enter. So this gives us 196,040.49. Okay, let's do one more and then I'll go over to Excel. We had, I don't know, maybe I'll do more. It's pretty easy on the calculator. But then I'll still do it in Excel. I think anybody going into business should be good at Excel. So on this one I got 200,000 again for the A over 1 plus 0.02 divided by 52 raised to the, and I'll put parentheses around this, 52 times T, which is now 10. Again, on the calculator, that you notice this formula right here is exactly the same as this, but instead of 1, we now have 10. And it's at the very end, so it even comes out nicer. So if I do a second enter, bring up my previous entry, you see I now have a 1 here, so I just replace that with 10 and press enter. That gives us 163,752.45. Our next one is 20, and then we go up to 50, I guess. So, again, very easy to do on your calculator. I just do a second enter to bring up the previous entry. Left arrow over and change that to 20. And this is 134,074.32. T is equal to 30. Again, I go to the calculator, do a second enter, bring up previous entry. And I'll left arrow over and change that to 30. And we got P is equal to 109,774.99. This is assuming my eyes are seeing all these correctly. I should have my glasses on, but the headphones kind of hurt my glasses when I have them on. Of course, I was watching TV when I said that. What did I just say? The headphones hurt my ears when I have my glasses on. House on the Haunted Hills on. The remake. Now do second enter, bring up previous one. Change that to 40. And I got 89,879.62. And let's put in 50. So I'll do second enter. And change it to 50. And we get a P is equal to 73,590 and 04. Okay, well, let's put this into our or into Excel. Sorry, it's a little tricky to put into Excel, but it's worth it because then we're set up for life, or until the spreadsheet becomes corrupt. So A is our ending amount, so we need that. Okay. So ending amount, and that was 200,000. We also need rate, which was 2%. We need in, and I'll just put in instead of number of times compounded per year, just make it shorter, which is 52. I guess those are the three things we're given, aren't they? Okay, now I think we're wanting T here. 1, 10, 20, 30. I think it's the same as the previous problem. 40 and 50. And then wanting P here. Okay, so let me come down here. And this will be equals. And let's go to our formula. It says A divided by. Well, A was in B16, so do $B, $16, divided by. And we'll put a beginning parentheses, 1 plus R. So I'm going to put parentheses around it. So I'll do beginning parentheses, R, which is $B, $17, divide by 100, close parentheses. That part changes it to a decimal form. And then divided by N, which was in B18. So $B, $18, closing parentheses. Now there's a closing parentheses on the bottom, so I do caret. Beginning parentheses in, which is on $B, $18, times, I don't want closing parentheses there, almost screwed that up, times t, which is b20. Now notice the t doesn't have the absolute referencing, doesn't have the dollar signs on it. Now if I press enter, I know what it should be because I just did it in the calculator. So it's handy to do it at least by hand once so you can see if you plugged in your formula correctly. Well, now if I take that and I fill across, I can double check my numbers, and that'll give me my answers. Okay, last problem. This is finding the effective rate of interest. Now the book describes this. You got your actual rate of interest, and then what's the effective? What's the actual amount type of deal, corresponding to a nominal rate of 8% per year. If I had the book in front of me, I'd read a better definition of what I just said. But compounded annually, semi-annually, quarterly, and monthly. Okay, this is our formula. It's not a hard one. Again, we're going to do most of it in Excel, though. Okay, annual rate of 8%. So R is 8%. And that's equal to 0.08. Okay, so our effective rate, A says annually. Well, annually means n is equal to 1. So our effective rate is going to equal to 1 plus R over n to the n power minus 1. So we got 1 plus R, which is 0.08, divided by n, which is 1, raised to the 1 power minus 1. Actually, that one I could probably do in my head. That one drops away, that one drops away. Parentheses are then gone, and I got 1 plus 0.08 minus 1. 1 minus 1 drops away, and we come up with 0.08. Now B says semi-annually. So n is 2. So our effective rate is 1 plus R over n to the n power minus 1. So we got 1 plus 0.08 divided by n, which is 2, squared minus 1. Okay, put this in our calculator. We've got a beginning parentheses 1 plus 0.08 divided by 2, closing parentheses, caret 2, and minus 1 at the end. And we get 0.0816. That should be effective rate down here. Screwed that one up. There we go. And we do C and D also. C is quarterly. So N is 4, and D would be monthly. So N is 12. So our effective rate here would be 1 plus R, which is 0.08, divided by N, which is 4, raised to the 4th power, minus 1. And this one is 1 plus 0.08 divided by n, which is 12, raised to the n power, which is 12, minus 1. So we got beginning parentheses 1 plus 0.08 divided by 4, close parentheses, caret 4 minus 1. Doesn't really see how many decimal places to take it out to. I guess 4 maybe. 0824. Because then actuality would change that back to percent form. You know, that first one would be 8%. This would be 8.16%. This would be 8.24%, and so on. Okay, this one. Do beginning parentheses 1 plus 0.08 divided by 12. Close parentheses, caret 12 minus 1. And we get 0.08 293. So 0.0830. So 8.3%. Okay, let's look how to do this in Excel. We need R, so we need our rate. And that's 8%. So then here I'm going to have N, I guess. I'll have 1, 2, 4, and what's the last one? 12. And then we want to find our effective. Effective rate. So here we're doing equals, and our formula is this right here. So beginning parentheses, 1 plus R over N. Well, R is in B27, so I do beginning parentheses, $B, $27. And it puts a little box around it, so it's pretty obvious whether you got it right or not. Divide by 100, change it to decimal form. And then divide by N. N is in B29. And we don't want the absolute referencing on that because we're going to fill it over. And then close parentheses, caret, B29, so we're raising it to the N power, minus 1. Now I'll come over here, click on that cell, put my mouse in the lower right hand corner till it becomes a plus. Click and hold down my left mouse button and fill over. And that'll give me my other answers in Excel. And the beauty of this now is if I come up here and change it to something else, like 2%, it automatically updates them. So I don't have to sit there and figure it out. Let me save that. And I think that was last, yeah it was. So let me go ahead and stop the recorder here.